Hello Professor, my name is Gautam. I'll be explaining the second problem of the homework 5. It is given that fx of y is equal to a upon y square x given the limits y is greater than equal to 1 and x is between 1 over y and y. For the first part we have to find the non-zero definition region of this function. Now we can, since we are given that y is greater than equal to 1, that will be this line, the horizontal one. Now for x, the limits are from 1 by y to y, which will be a curve like this. And for the y equal to x line will be a normal y equal to x line, as we know that. Now for the non-definitive region, we need to find the intersection of these three parts, which will be nothing but this region as demarcated in the graph. And this is the non-definitive region, non-definition region of the function fxy. Now in the second part we have to find the value of a so that the given function is a valid joint density function. For the given function to be a valid joint density function, we can say that the double integral of the given function is equal to 1. Now we substitute the value of the limits, that is for x the range is from 1 by y to y, and from y, for y the range is from 1 to infinity. Therefore we integrate this. First we initially integrate this with respect to x, and then again we integrate it with respect to y. So when we integrate with respect to x, we get the value as, since this is constant, we can take it outside, and this is ln x over the limits 1 by y to y, and when we substitute it we get the value as 2 ln y. And when we again we have to integrate this, since this is a double integral, we have to integrate this with respect to y over the limits 1 to infinity. Now now for this one we use the substitution methods, wherein we can say this, that ln y is equal to w. Therefore y square will be e raised to power 2w and y is equal to w. And when we substitute the values here, this gets tracked off with the value as e raised to minus w and 2a, and the limits will change from 0 to infinity. Therefore when we integrate this, we get the value of a as a is equal to 1 over 2. Now for the third part we have to find the marginal density function of fx and fy. The marginal density function of fx can be given by integrating it over integrating the given function with respect to y. Now for the initially the limits will be from 1 by x to infinity when x is between 0 and 1, and when we calculate it we get the value as 1 by 2 in the limit 0 to 1. And for the second limits, that is from 1 to infinity, we integrate it from x to infinity, and we get the value of that as half of x square. Now similarly for fy of y, we calculate it, that is the marginal density function over the limits from 1 by y to y, and y will have only one limit, that is from 1 to infinity. Therefore we again get the same equation, and when we again get this equation ln y upon y square, and the graph of fy of y will be like this. Now for the fourth part we have to verify that these two given functions are valid joint density functions. For that we have to just show that the limits, the integration over the limits is equal to 1. Therefore for fy of y we calculate, as we have just calculated fy of y, and we integrate it over the limits, and when we substitute the value, this is again the similar equation that we get here, and when we substitute the value, this is equal to 1. Now for fx of x, we knew that this is the value half plus 1 by 2 x square, and when we integrate it over the given limits from this, we get the value of fx of x is also equal to 1. Thus it is verified that both the given functions, individual functions, are valid joint or valid density functions.